Okay, so teacher didn't mention any of this in the during lessons, but he did mention that this might come out in exam, and this one is the kbat question, and I'm going to try and only this. I'm only going to talk about this question because everything else is kind of basic. I think that most of you can handle it by yourself without anyone's teaching. Self study. It doesn't matter how smart you are. It really isn't that hard compared to this. So I'm gonna teach this for SPM. Um, there are two kinds of questions. Number one is they ask you to compare four similar items, and number two is they're going to ask you to create the most optimal version of of a certain item. So we're gonna do the comparison one first. So what you need to do is you need to understand the function of an air fryer. So the air fryer here is used to heat up stuff, or stove to heat up stuff. So most of it is going to involve heat, temperature. So um, you need to try and compare and contrast all of the properties and make the most suitable choose the most suitable one. So number one, what is the function of a fuse in the air fryer? So a fuse's function is actually, I wrote it here, to cut off the current when it is in excess. So it is to break the circuit when it is overloaded. You want to break the circuit when it's overloaded, because if you don't break it, it will cause a short circuit, it will burn, and then your thing will not work anymore. So the fuse is to break it in advance so that nothing bad happens. What is meant by 240V 1500W on the label of the air fryers? So this voltage and power thing is what I call the optimal conditions. So you want to make sure that you get 240 volt in your air fryer and produce 1500 watts. So yeah, basically this thing runs on 1500 watts maximum. So yeah, the voltage is the optimum voltage, like the minimum voltage the voltage that it wants to make sure that it runs the best, if you get what I'm saying. Yeah, the W is the power that it is supposed to work on, and the voltage and the voltage next to it is the voltage that is supposed to work on. So you want to, so this is important for your upcoming mission. Can discuss the specifications of the four air fryers to cook food quickly and safely. So this one you don't have to do a table yet. You just have to discuss what the specifications are. So there are a few that you can look at: heating element, number of fan blades, number of coils, and fuse breaking point. So yeah, you need to mention all four of this. So you have to mention all four. First of all, heating element. You want heating element. You need a heating element with high resistivity. Why? Because it increases it increases resistance. That's number one. Number two, you need it's the number of fan blades. Should be increased or high. Oh my god. Oops. Should be increased, and the reason why is to disperse heat quickly. Number three is number of coils. It is to oops, it's saving for some reason. Increase, and this is because you want to, because the longer the wire, the more the coils, the longer the wire, and the higher the resistance. And lastly, fuse has to be low. Why? Because does not over exceed. Power by too much. Okay, what do I mean by this? So When you want to answer this question, you have to mention all of these 4 elements because they all have similar characteristics, but they have a main difference in these 4. Heating element. Normally, when you want a heating element, you need to choose nichrome because nichrome has a high resistivity. Constant tan is okay, but if you're comparing constant tan and nichrome, you need to choose nichrome because nichrome has twice the amount of resistivity of constant tan. So why do you want high resistance? Because high resistance means more energy will be released. So when more energy is released, more heat will be released because normally resistance is released in the form of heat energy. The resistance of the wires results in release of heat energy. So the higher the resistance, the more heat energy is released. So the faster your air fryer, the more efficient your air fryer is. Number 2 is the number of fan blades. Why do you need a larger number of fan blades? This is because the more fan blades there are, the faster heat is dispersed towards the food because the air fryer is used to heat up food, and the more fan blades there are, the more heat is actually released to go onto the food. So it makes it more efficient. Number 3, number of coils increase. As I said, you want to make sure that the length is longer, because if you have two coils and then you have 3 coils, this is longer, right? The longer the wire, the larger the resistance. So that means more heat released and fuse. Why the fuse should be low? Because if you make it too high, it might damage the air fryer before it actually actually breaks the circuit. So you want the fuse to be higher than the optimal current, but not too high. And how do you know? How do you find the optimal current? So you have to use a formula. P equals to V squared over R. So you know that P is 21500, and then equals to 2140 square over R. I'm using the wrong one. It's supposed to be current. So just use it again. P equals to VI. So I equals to this, which is roughly around 6 ampere if I remember correctly. So 8 ampere is lower than 10 ampere, but it's still higher than 6. So you want to use the 8 ampere one. So with this, you want to determine the most suitable air fryer. So you look at the number of coils first. 1, 2, 3, 4. 1, 2, 3, 4, 5. And here also 5. So these 2 are out already. And then number of fan blades. This one is already out. And then heating element, nichrome. You don't want constant tan. So this one is correct. Constant tan, and then fuse. So you can see that I did not cross D at all. So D is the most suitable air fryer. You need to give your reasons why. So air fryer D is the most suitable because it has a good heating element. It has a big number of fan blades, a lot of coils, has the most coils, and has a suitable fuse. And then that's the answer. Okay, number 6 is similar. Discuss the suitability of the 4 types of electric stoves based on the features given. So again, remember, just now I was answering with essay-ish form, but it's better to do a table. So I actually have the answer here. So yes, metal resistivity at 20 degrees Celsius, thermal conductivity, melting point, and oxidation rate. So I'm gonna write them all. So I have the answer here actually because I did it a while ago. I'm going to construct a table, a very ugly one. Okay, so feature and explanation. So number 1 is high metal resistivity at 20 degrees Celsius. So why do you need a high metal resistivity at 20 degrees Celsius? Because you want to increase resistance. Number 2, high thermal conductivity. Why do you need high thermal conductivity? Because a better thermal conductor is better at dispersing heat. A heat insulator normally traps heat for itself, but a good heat conductor is good at conducting heat, is good at spreading heat. So the higher the thermal conductivity, the faster the heat is actually spread. So you can say here that the heat is spread faster and more evenly. Number 3, high melting point. Why do you want a high melting point? Because you want to conduct high temperatures of heat. Because remember, you're using a stove, so you want to make sure that your thing doesn't melt, right? And lastly is low oxidation rate. So why do you want a low oxidation rate? Because it decreases corrosion. Why do you want to avoid corrosion? Because the stove will last longer. No, I won't say last longer. I would say more durable. Stove does not rust easily. It's more durable. So yeah, there are many types of characteristics that you have to keep an eye on, but they all lead to heat being used more efficiently. You want to care about efficiency of heat. Determine the most suitable electric stove. Give your reasons. So you want a high melting point. So Q and S are definitely not in the equation. You want to take the two best ones. Okay, and then okay, next is metal resistivity. S is quite good, but it's but NR is second best, so we include X, S and R. So P and Q get 1 extra X. Thermal conductivity, high, so these two. And then oxidation rate, high, these two. So even though this is a very high resistivity, you still want to choose R, because R has a pretty okay resistivity, but it's also good at conducting, it has a good melting point, and it also has a low oxidation rate. This thing will melt fast, so you want to choose R. R is the most suitable electric stove, because it has a good metal resistivity, a high thermal conductivity, the highest melting point, and a low oxidation rate. Okay, the last question. Explain the modifications based on the following aspects. Number of coil turns of the heating elements. So that's 1, density 2, diameter 3, type of material 4. So I'm gonna do another table. So modification, explanation. I'm not gonna write full sentences. Okay. Number 1, number of coils is many. Okay, you want many coil turns. You want a high number of coil turns. Why? Because it increases the length which increases resistance. Next, you want low density. Why do you want low density? Because if you have a high density, the thing will be very heavy. So, let's say the material is lighter. Diameter is small. Why do you want a small diameter? Because small diameters have larger resistance. I'm not so sure about the explanation behind it. But yeah. And lastly, type of material used. You want to use nichrome because nichrome has a high resistivity. So yeah, that's the answer. So what can I sum up overall according to this? Number one is your wire should be long, so has many coils. With our most suitable item. Number one is wire has many coils. Number two is material is nichrome. Number three is I'll put it number one as well. Small diameter. Number three is high melting point. Four is low oxidation rate. Five is most suitable fuse. Number six is yeah, I'll put an explanation here. Resistivity. Number six is good conductor of heat. Number seven is good at dispersing heat. So this one is fan blades. So these are the ones that I found while doing this. Number 8 is density. Density low. So these are the ones that we found out according to all the questions that we have done. I actually did another one. And this should be the most possible question. So they will ask about mainly this material used. They'll ask about the number of coils, and they'll also ask about the diameter. So this and this, and lastly, they actually ask about one safety feature. So they might ask about the fuse. So or has a fuse in general. So I think you should focus on these three. Number of coils, especially this one. This one and the type of material are going to come out, confirm. If they ask questions like this. But everything else is more towards logic lah. Because if you so yeah, just keep in mind about all of these answers. And if they ask for the material, you want to, if they don't it's not always going to be nichrome. It might be constant tan and tungsten. But usually it's nichrome, because nichrome is the largest example of resistivity. Like the best example of resistivity. So yeah, just try and get all of this and fit them into your characteristics of your thing if they ask for any of this. But I bet that if you do ask this, they will definitely ask about the coils. Coil and material are the confirmed ones. It comes out every single time. Why? Because they want you to know that the resistivity and the length of your wire is very important. But one thing that they don't mention is the diameter. So yeah, be careful of the diameter. Just know that a smaller diameter actually gives out more heat. And I think that's it. I don't think all of this will come out. No, all of this will not come out, but it's worth taking note of everything that you see. But according to my workbook, the ones that I take are the ones that actually came out. So know the function of the fuse. Know why wire has many coils. Basically, think of wire and coils as the same way as you think of intestines and surface area. You need a large surface area to absorb more nutrients, and you need a longer wire to increase your resistance.